Welcome to MATLAB. Today, you're on your journey to discover the geometric meaning of factorization of algebraic expressions by taking out common factors and grouping. Today, you're provided with a lab observation sheet. If you look carefully at your lab observation sheet, there are a number of models made by using algebraic tiles. An algebraic tile is a rectangle or a square whose area is written on it. Now, suppose my tile has an area 5x square. Then, how do I find its dimensions? I need to work backwards. The dimensions of my tile may be 5 and x square or 5x and x or 1 and 5x square. However, I cannot ascertain accurately the dimensions when I have a single algebraic tile. What happens when I have two or more tiles whose breadth matches? Now, is it possible for me to work out its dimensions? I can find the breadth of my tiles by taking out the highest common factor or its HCF. The HCF of 5x square and 15x is 5x. So, the breadth of my tiles are 5x. Can you determine the length of each tile? Is it not x and 3? Now, can you write the area of the big rectangle in terms of the sum of the areas of each algebraic tile? Also, can you determine the area of the same rectangle in terms of the product of its length and breadth? So can I say that 5x square plus 15x, that is the area of the big rectangle as a sum, is nothing but 5x into x plus 3, area of the same rectangle as the product of its length and breadth. Have I written my algebraic expression as a product of its factors? Let us see another situation. Suppose we have 4 algebraic tiles arranged as follows. Can you now determine the length and the breadth of the big rectangle? So if you observe the tiles in the first row, what is the HCF between a square and AQ? Is it not A? Observe the second row. What is the HCF between AQ square and Q cube? Isn't it Q square? Now observe the first column. What is the area? What is the HCF between A square and AQ square? Is it not A? Can you determine the HCF between the terms in the second column? AQ and Q cube, is it not Q? So, can I write the area as a sum, that is A square plus AQ plus AQ square plus Q cube as the area of the product of its length and breadth as A plus Q square into A plus Q. Have we found the factors of our algebraic expressions? Have fun discovering more about factorization.